Hey guys, welcome back to 18. In the last video, we calculated delta G, Gibbs free energy, using our new formula, and we were able to do that at a given temperature. Today, what we're going to talk about is that temperature dependence. Okay, so if we can understand at what temperature the reaction will be spontaneous or non-spontaneous. Manipulating temperature in chemistry is actually a pretty easy thing to do. It's one of the easiest things for us to monitor. It's one of the easiest things for us to manipulate. So it's a useful tool for us to have. So that's what we're going to spend the next section talking about is the temperature dependence of spontaneity. So does temperature affect it? And if so, how can we change the temperature? Okay. So first, here is our formula for delta G for Gibbs free energy. And it's just good to remind ourselves that positive is non-spontaneous and negative is spontaneous. So it's just good to have that in our minds or on our papers so that we can know what it is that we're striving for. So spontaneous, non-spontaneous. Okay. So let's look at some examples here. So in the first example, we're going to look at a condition when delta H is negative and delta S is positive. Okay. So let's think about what this scenario might look like. So if delta H is negative, negative delta H is an exothermic reaction. Okay. So that means that while this is happening, heat is exiting the system. Okay. Exothermic tends to be a favorable condition, right? We see a lot of chemical reactions are in fact exothermic. Okay, the other thing here is delta S is positive. Well, if delta S is positive, that means that it's getting messier or energy is dispersing. That's also a favorable condition, right? Cleaning takes work. Becoming messy just happens to happen, right? So we've got two scenarios here that are somewhat favorable conditions. Now, if we think about the math of this, right? So we're going to have a negative number minus some other number, okay? So negative number minus a positive number, or minus some other number. So a negative minus a number or a negative plus a negative will always result in what? Yeah, negative delta G. There is no way that you can add -1 plus -1 and it can be a positive. It's just never going to happen. So it doesn't matter what this value for T is, if it's a big value or if it's a little value, it will not affect the fact that this is always going to be a spontaneous reaction. So two favorable conditions. Doesn't matter what time. Sorry. Two favorable conditions. Doesn't matter what temperature it's at. This will always be a spontaneous reaction. So delta G will be negative at all temperatures. It will always be spontaneous. Okay. Let's look at the next scenario. We've got a positive delta H. So that's endothermic, right? Energy's entering the system. And we've got a negative delta S. So negative means that we're cleaning up. We're becoming more organized, okay? So endothermic, we're adding energy into the system, or it's taking energy from the surroundings. Negative delta S means that it's becoming more organized. So this would be a scenario where we've got really two unfavorable conditions. It's taking energy from the surroundings and it's becoming more organized. So we're going to have a positive number, right, minus a negative number. Okay. So a positive minus a negative is another way of saying a positive plus a positive. There is nothing that you can do to make this anything other than a delta G, okay? So it doesn't matter if this is a big number. It doesn't matter if it's a little number. No matter what that temperature value is, G will always result in a positive number. This will always be a scenario where this is a non-spontaneous reaction. Endothermic, unfavorable, cleaning up, unfavorable. So this is going to be a scenario that is never spontaneous. It doesn't matter what temperature, it is going to be spontaneous. Never going to be spontaneous. It's always going to be non-spontaneous. All right, so we looked at negative, positive. We looked at positive, negative. And we saw that those were all or none statements. Now what we're going to look at is if the sign is the same. So what if we have negative, negative, or we have positive, positive, okay? What we're going to see here is there is a temperature dependence, okay? So what if we have a negative enthalpy change and a negative entropy change? So negative delta H is exothermic, so heat is exiting the system. Well, that's favorable. And delta S is also negative, but that's the cleaning up, right? So cleaning is a bad thing. It's unfavorable. So we've got a favorable and we have an unfavorable, okay? So we're going to have a negative number minus another negative number, okay? Okay. All right, so we've got a negative minus another negative, okay? Here we're going to see that the temperature, this is going to depend on temperature, okay? So if we want this to equal negative delta G, we want it to be spontaneous, right? What we're going to need is for this portion to be a small number, okay? So if cleaning up is unfavorable, we need to make that as little unfavorable as possible. So if we want this side to be the side that is unfavorable, we want to multiply it by a small number so that our exothermic overcomes this cleaning up process. So what we're going to find is that this will be a negative number at low temperatures. So if this number is a low number, if it's a cool temperature, then it will be a spontaneous reaction. So this will be negative. This portion will be small enough to allow that to remain negative. But if T is a big number, so at high temperatures, if this is a big number, what's going to happen is this will be negative, and this portion will be large enough to overcome that negative, and it'll cause delta G to be a positive number, okay? So above a certain temperature, it'll be non-spontaneous. Below that certain temperature, it'll be spontaneous, okay? So when we've got the signs being the same, what we find is that it is in fact temperature dependent. So when we have a negative and a negative, low temperatures will be spontaneous, high temperatures will be non-spontaneous. Okay. All right. Now we have positive and positive. So we've got positive delta H. That is endothermic. It's taking energy from the surroundings. So energy is entering the system. And we've got positive entropy, which means it's getting messy. And that's favorable. Okay. So again, we've got unfavorable, we've got favorable. So this is in fact temperature dependent. So for delta G to be a negative, so for delta G to be a negative, what we're going to see is that this number over here has to be a big number, okay? So we've got a positive number minus another positive number, okay? So in order for delta G to be negative, this minus a positive number has to be bigger than the first one. So we want to subtract by a bigger number so that we end up with a negative value. So what we're going to see is delta G is negative at high temperatures. So this is going to be spontaneous at high temperatures. Okay. If we have a low temperature, so this is low, this number is going to be a smaller number. Okay. So what we'll see is we've got a positive minus a positive, but if this number of delta H is bigger, then a big number minus a little number would lead to a positive delta G. So that would be non-spontaneous at low temperatures. So for positive and positive, it's going to be spontaneous when the temperature is high and non-spontaneous when the temperature is low. Okay. So what we've looked at so far is a scenario where it's always spontaneous no matter what temperature. We've looked at a scenario where it's always non-spontaneous no matter the temperature. We've looked at a scenario where high temperature means spontaneous. And we've looked at a scenario where low temperature means spontaneous. Okay. So here's the 4 different scenarios that we've looked at. This is probably a pretty helpful chart to have near you during the exam, unless you want to memorize your way through this. Okay. So now this gives us the ability to ask questions in a different manner. Okay. So the question that we asked before, so this is the one that we calculated in the previous example, is we said calculate delta G at 25 degrees Celsius. So when we calculated delta G at 25 degrees Celsius, we found that delta G was positive 53.3 kilojoules, which is kilojoules. Okay. So we found that this was a positive delta G, so it was non-spontaneous. Now we can ask ourselves, determine at what temperature, if any, the reaction becomes spontaneous. So we know at 25 degrees Celsius, it's non-spontaneous. It's not going to happen unless we continue to input. But is there a temperature that we can heat this up to, or a temperature we can cool this down to in order to make this a spontaneous reaction? So to solve for this, we are going to do the following. We are going to set the equation equal to 0. Okay. Why 0? Well, above 0, delta G is positive, non-spontaneous. Below 0, delta G is spontaneous. So if I calculate the temperature at which delta G is 0, then I can say above that, this happens, below that, this happens. So we're just trying to find that baseline, and then we'll compare it. So we still use our equation, delta H minus T, delta S, okay? And in this case, we're solving for temperature. So we're solving for this guy right here. So what we're solving for is we're going to say at temperature, yada, yada, delta G will equal 0. And above that temperature, it's spontaneous. Below that temperature, it's non-spontaneous, or vice versa. Okay? So if we are setting delta G to 0, we were given delta H, so that was 95.7 kilojoules. We're solving for temperature, so that's going to be the variable that remains. And remember, delta S was given in joules, so remember we have to change the unit for one of them, and I changed delta S last time. So this is going to be 0.1422 kilojoules per Kelvin. Okay. Now it is our job to solve for T. So what I'm going to do is I'm going to add plus T times 0.1422 to get this to the other side. So if I add, these cancel. Whatever I do to the left side, I also have to do to the right side. Okay. So this is going to give me T times 0.1422 kilojoules over Kelvin equals 95.7 kilojoules. To get T by itself, I'm going to divide by 0.1422 kilojoules. Kelvin, so that cancels. Divided by 0.1422 kilojoules over Kelvin. So kilojoules cancel. We're left with the unit Kelvin, which is helpful because we're solving for temperature. So I'm going to take 95.7 divided by 0.1422, and at 673 Kelvin, delta G will be 0. Okay. Now we have to determine, so at what temperature does this become spontaneous? So is it spontaneous at 673? No, it is not. we have to decide, is it spontaneous above that or is it spontaneous below that? So we are looking at a scenario where delta H is positive, delta S is also positive. So we are looking at this scenario down here at the bottom. Okay. So this tells me that our reaction will be spontaneous at high temperatures, non-spontaneous at low temperatures. So if it's spontaneous at high temperatures, that tells me that this reaction will be spontaneous above 673 Kelvin. Okay. So at what temperature, if any, does this become spontaneous? It becomes spontaneous above 673 Kelvin. I hope you guys found this helpful.